So this is a quick presentation that I gave in a graduate level syntax class um, at Arizona State University. And I just thought that I would record it because I thought that it was kind of an interesting topic to research and kind of unusual as far as syntax topics are concerned. Obviously, usually when people study syntax, obviously they're studying language. So musical syntax is definitely something that's unique. Unfortunately, not a lot of linguists are musicians, and not a lot of musicians are linguists. I'm neither, but I am a little bit of both, and so I thought that I would hack away and try to discover some sort of theory of musical syntax. So this is my very incomplete presentation of musical syntax. So it starts with the composer Leonard Bernstein, who was an American composer in the 20th century. He was the director of the New York Philharmonic for many, many years. He was known for sort of his bright, upbeat tempos. He was a master of conducting the German modernist composers like Mahler. And he wrote popular music that we know from like West Side Story and the famous American opera Candide, which is based on the novel by Voltaire, and many other wonderful works that Leonard Bernstein left behind. And he also didn't just do music, he did dabble in philosophy and just aesthetics, and also very briefly in linguistics. In a series of lectures that Leonard Bernstein delivered at Harvard in, I believe, 1973, he developed a theory of comparing music to language. And in the second lecture of the series, he compares musical syntax to linguistic syntax. So here we have our quote from conductor Maestro Bernstein, who's pictured right here, that non-musicians could understand the inner syntactic functions of music by analogy with similar functions in language, cognate processes operating in both music and language which are discoverable by linguistic method. So he's comparing musical phrase structures to linguistic phrase structures. And, you know, if we just kind of apply our sort of rustic common sense, we can see that there are certain similarities between music and language. Definitely, they both have phrases. They both have an emotive effect. And that's kind of the problem that Bernstein runs into, is that music seems to only have an emotive effect, whereas language has both an emotive effect, which is poetry, and a non-emotive effect, which is prose, a plain, literal effect. And this literalness is not something that we can find in language. So here's the problem kind of laid out. Bernstein says that there are chosen elements in language and music. And in language, these chosen elements are your morphemes, your words, your phones, your sounds, the basic elements, sort of the concrete elements, the base, almost in Marxian terms, of language. Whereas in music, it's just your key, your meter. I would even include the instruments you're using, the tonality, intonation probably, things like that. Then there's the underlying strings of language, which is the deep structure. So the deep structure, as we know in syntax, is the structure in all of its, hierarchical complexity. It's all of the sort of merge and move possibilities. All of the branches are existing in the large deep structure. And the surface structure is just what we hear or what we say. So when we say a sort of an interesting sentence syntactically, like Bob tried the door. You know, we can use a small v in the VP shell to create a large deep structure to account for the surface structure of a sentence like John tried the door. And then after we have sentences like John tried the door can, of course, be part of, but it is not necessarily part of, but it can be part of a piece of poetry or a great work of language, which is what Bernstein calls a supersurface structure. So it is a surface structure, I would argue, because it's still every utterance has to be a surface structure. That's all that the utterance really is. But it's just a surface structure in that it's better than all the other surface structures, all the other possibilities, and that's what makes it poetry. There's something wonderful about it, in plain terms. Music, on the other hand, we have our chosen elements, the underlying strings, which would be sort of what your melody is, independently of everything else, what your harmony is, independently of everything else, what your rhythm is, independently of everything else. You know, these general, groupings. And then there's a deep structure, which he would call prose in music, and that's problematic. And then there's a surface structure, which is music. So certainly music is equivalent to poetry. I mean, something like Mahler or Beethoven or Bernstein or the Beatles is a super surface structure, like poetry. But for Bernstein, he labels it as only a surface structure because it is just what we hear also, It's of course there's something behind that, though, which is the prose or the deep structure. There's all the deletions. Especially Bernstein has a famous lecture from television, which I believe he delivered before these musical lectures, where he talks about Beethoven's Fifth Symphony. And he's actually using copies of Beethoven's various revisions of especially the sort of overture, the intro to the first movement, the da-da-da-da, da-da-da-da, that part. And he plays them with his orchestra, the various revisions. And he shows you how Beethoven achieves this surface structure by deleting out the deep structure, by deleting out all the unnecessary parts of the music that are just boring prose and don't belong in the music. So what is the prose? It's also the finger exercises that people practice, or the scales that people practice, or the etude studies that you do in learning to become a musician. Those aren't music. Nobody would go to a concert where someone was playing, finger exercises or whatever. But they are a very integral part of music, and they do have all of the sort of just descriptive qualities of music. They have rhythm, they have harmony and melody and so forth. But nevertheless, they're not music. There's a guy in England named Sutcliffe, who's, I believe, has a master's degree in music, and is himself a professional musician. And he wrote a book on musical phrase structure, and he has most of it online, actually. And the citation is at the end of the presentation. So you can get all of the stuff that I have from Sutcliffe's book online, because I got all of it online, actually. He has quite a lot up there. So he says that, a sort of basic musical phrase in tonal Western music is this here. That there's a phrase at the top that bifurcates into an opening section and a closing section. And the opening section contains a static harmony, whereas the closing section contains a dynamic harmony and then a cadence, which itself bifurcates into a 5-chord and a 1-chord. So looking at this, if you're a linguist, this obviously looks quite a lot like a sentence structure. Just looking at it, if we imagine that phrase is TP in the sort of terminology that I'm familiar with, if it's a tense phrase, like a sentence, then the opening section would be our subject in English, which would be a noun phrase, or a determiner phrase, or a quantifier phrase, what have you. And then the closing section would actually be where our T bar is, and the dynamic harmony would be our T. And then the cadence phrase would be where the VP is located, and chord V and chord 1 would, I suppose, be the verb and the object. So here are some adaptations that I applied to this structure in order to provide a linguist's account for maybe what's going on in music. I think that it's very helpful that musicians are the ones developing these theories, because they're obviously the ones that know much more about music than we do. But linguists can provide some of the terminological help and typological help along the way, because linguists have 50 or 60 years of experience of doing that. So I said that the dynamic harmony was in the position of T, and that would make it the head of a tense phrase if the musical phrase is the same as, or equivalent to, or analogous to a sentential or lexical phrase. So that makes the dynamic harmony the head of the phrase structure, just as the T would be the head of the phrase structure, and therefore the overall phrase is a dynamic harmony phrase. Since the static harmony was the head of the opening section, I just called that the static harmony phrase. And then we have the bifurcation at the DH bar, which is a dynamic harmony bar, which goes to a cadence phrase, which has the cadence head. And then I think there's an empty position after the cadence head that is occupied by another phrase. Sutcliffe has it as a 1, because this would be just a very, very short phrase where you just played and then you went to 1 and you ended. But of course in music you don't just go to 1 and end. You of course continue on. So then I expanded it and made it so that the static harmony phrase has a specifier as well as a SH bar level to sort of fit with syntax X bar theory. And the DH bar also has the DH as a specifier, and then the cadence phrase has a specifier, and it also has a complement position. So it's a fully fleshed out now sort of Chomskyan sentence structure. And so this is how Sutcliffe applied his theory to a phrase from the Four Seasons. So if you don't read music, I will sing this phrase very poorly now. Da 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 da. We're all familiar with this phrase. So if we think about it, it's basically in two phrases. And so if you look at the bottom, I have it diagrammed in two phrases, and I'm going to sing them again so you can hear the phrases. So there's a static harmony phrase, and there's a cadence phrase. Those are the two phrases that we have. We have a static harmony, which is the head of the static harmony phrase, and a cadence, which is the head of the cadence phrase. So here is the tune again in my lovely voice. So, did you hear it? When I went at the part where I go da 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 da, in your head you're going, okay, we're getting around to the end of a phrase. We're coming back to something. And that is exactly where the cadence phrase is. And that means that everything before that is part of the static harmony phrase. So da 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 da. That's the static harmony phrase. And then da 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 da. That's the cadence phrase. And if you think about it, it splits up very nicely into those two. One of them is certainly not like the other. So if we look at the phrase structure, actually what I was just singing was the voice lead, the melody. Da, 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 da. That's just the melody. It's not a harmony. And so the harmony is basically what's going on in all the boring notes, the quarter notes, and then the syncopation on 3. That's the static harmony for that phrase, and it just repeats. And then when we get to the da 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 da, the cadence phrase has a voice, and that's what I sang. And then there's a da do dee do da, some kind of cadence, which is on a 5 chord. And then it returns to the tonic 1 chord you see on the final quarter note there. So this is the phrase structure in action. There is some actual real scientific proof for this theory. It's not all just flimsy soft science stuff. Some cognitive scientists and neuroscience scientists have actually done some kind of brainwave studies on this. A study by Mace et al. Found that musical syntax is processed in Broca's area of the brain. What they did in that study is they gave people both linguistic syntactic incongruities and musical syntactic incongruities. And these people were trained musicians, and they had them listen to these incongruities. And while they were listening to them, they were monitoring Broca's area, and they found that the left side of Broca's area, which is what Broca's area is, but today in neuroscience, it's more understood as part of a larger structure. Broca's area is just the left hemisphere part of a larger structure that processes information. And so both the left and right hemispheres were activated for both music and linguistic language, and both were necessary and inherent and required for linguistic and musical. So that shows that there's a lot of overlap and a lot of use of the same neurons in this processing, which would probably mean that they have to have similar structures. Featherstone et al. Kind of did a similar study where they just asked people how wrong incongruous language syntax was perceived, and they also did some brain scan studies. And they found that incongruous language syntax was perceived as more wrong than incongruous musical syntax. And this makes sense. When you hear something just that kind of is wrong musically, syntactically, you might actually just think it's interesting. You know, there's a lot of sudden leaps in music that come out of nowhere, and that's what makes music interesting sometimes. Whereas in language, if you do that, sometimes it just sounds schizophrenic or aphasic or whatever. And Patel, in this study, she came up with a theory. It was more of a review study where she was looking at several different theories. But she came up with the idea that there's a shared syntactic integration resource area, so that there's an overlap in the neural areas and operations which provide the resources for syntactic integration. So what this means is basically what the other studies are saying, is that there's shared neural work going on, that that the area of the brain that processes syntax is also involved in other things, including music. So that is the presentation. It's about 5 times longer than it was in its original formulation, so I think I got everything out that I needed to. Here are my references, and please feel free to contact me if you have any questions or if you have any comments about this presentation.